My name is Erin Alanis, and this is my physics project. My two lovely assistants are Emily Love and Daniel Segura. Today we're going to be talking about friction, force, and work. Right now I'm going to demonstrate the differences between friction. Here we have a lovely carpet, my lovely self, and Daniel. Daniel is going to drag me across the carpet onto tile floor to demonstrate the differences of friction. Can you tell the complication he has on this carpet? Watch the changes when he goes onto the tile. Much easier. A little less complicated. Okay, now we're going to go ahead and talk about a few frictions. Friction forces are parallel to the surfaces in contact and oppose motion or impending motion. There are two types of friction. There is static friction and kinetic friction. Static friction is associated with objects at rest or not in motion. Kinetic friction is associated with objects in motion and is considered constant between surfaces. Now I'll give you an example of both static and kinetic friction. Here we have a box and a lovely cell phone. When you put the box at an angle, the phone will either slide or stay still. With static friction, the phone stays still. With kinetic friction, the phone slides down. Now we're going to talk about force. Force is a vector quantity. Force is a push or pull. The standard unit for force is newtons. Daniel will now give an example of what force is. On this side, we have a chair. He's going to apply force to the left, and now force has been done. Now I'm going to show you a free body diagram of what that kind of force looks like. So here we have Daniel. Here's the chair. He's applying a force to the left. This dot represents the object. The force facing down is the force of gravity. The force going up is the normal force. These forces are equal because the chair doesn't move up or down. The force Daniel applies to the left is the acceleration force, giving the force of friction equal because it's going at a constant speed. So that is what the free body diagram looks like. Now you're going to answer some true or false questions. True or false? The normal force always points up. If you answered false, you're right. One more question. True or false? A force is required to keep an object moving at constant speed in free space. You guessed it again. It's false. The formulas for force is F net equals mass times acceleration and force equals mass times gravity. Gravity is always 9.8 meters per second. Now I'm going to show you an example of some equations of everyday life to where you can calculate the force. Alright, so say you have a force of 200 newtons. You have gravity, which equals 9.8 meters per second, and you need to find the mass. What do? You use the formula F equals mass times gravity. So you're going to set it up to where 200 is equal to the mass times the gravity. Then you're going to divide each side by 9.8 which gives you a mass of 20.4 kilograms. Mass is always measured in kilograms or in a neutral unit. Next, we're going to move on to work. Work is a force applied over a distance. Work also involves force. The formula for work is force times distance. Work is a scalar quantity. Now, Daniel's going to demonstrate the kind of work that we use in athletics, probably. He's going to go ahead and show not just a normal push-up, but a push-up with a clap. Notice how he has to go up and down, moving his arms vigorously. Alright, now I'm going to show you how to calculate work in, again, everyday problems. Okay, so you have a force of 100 newtons. The object that has the force of 100 newtons moves 5 meters. So your distance is going to be 5 meters. You need to find the work. So the formula is work equals force times distance. So you're going to set your problem up to 100 times 5, which equals 500 joules. Another thing about work is that it's always measured in joules. Another problem is that work is also involved with power. So the formula for power is power equals work divided by time. So if you're looking for the work, when you have the power of 800 watts in 10 seconds, go ahead and set your problem up. Power is equal to 800. You're looking for work, and your time is 10 seconds. Multiply each side by 10. Once you do that, you will figure out your work, which is 8,000 joules. Now that you've seen examples of friction, force, and work, I hope you got a lot out of this lesson. Thank you for watching, and here are our credits.